All right, guys, so we're going to do a brief review on solving exponential equations. I know a lot of you have seen this in algebra already, but chapter 1 and 2 are mostly in algebra 2 review, so it is what it is. Change of base formula. Most scientific calculators will only calculate a log base of 10, meaning you can't even type in the base and it just automatically assumes a base of 10. So if you need to actually use a base other than 10 and you have a scientific calculator that only calculates a base of 10, then you would use what's called the change of base formula. And to solve, if you are trying to eliminate an exponential base, you would apply a log with that same base, and vice versa. It works the same way. If you're trying to get rid of a log with a certain base, you would apply an exponential base of that same value. And we'll see an example of that later on. But let's start off here. So I can't actually get to x because it's an exponent. So the only way to get to x is to get rid of the exponential base so that it is no longer an exponent. So to start it off, I am going to, as we stated here, give this a log of the same base, but make sure that whatever you do to one side of the equal sign, you do to the other. So I'm going to bring both sides down, 1 over 16, and this would be 4 to the negative x minus 1. From here, a log base with an exponential base of the same value will get rid of each other, and that will leave you with negative and in parentheses x minus 1. Now, it's no longer an exponent because you no longer have a base. And from here, we're going to drop down the right side. If you're trying to calculate log base 4 of 1 over 16, this is what I was referring to if some of you only have a calculator that when you type in log, it doesn't let you punch in a certain base because it only calculates a log base of 10. You can use what's called the change of base formula. So log base 4 of 1 over 16 is the same thing as me calculating log of 1 over 16 divided by log of 4. So we're going to calculate that first. So we're going to take log of 1 over 16, make sure the 1 over 16 is in parentheses, close that parentheses, press equals because you're taking the log of it, and then divide by log of 4. And that should give you negative 2. So moving this up because I'm out of room, negative x minus 1 equals negative 2. Now you have two options on the left. You can either divide both sides by the negative 1 to get rid of the negative and therefore get rid of the parentheses as well, or some of you prefer to distribute the negative 1. Doesn't matter which way, long as you're doing it correctly algebraically, it's all going to come out the same answer. I'm just going to divide both sides by negative 1 first. Again, once you get rid of what is distributed in front of it, the parentheses can be eliminated, and that'll give you x minus 1 equals 2. And then add 1 to both sides. Whatever you do to one side, you do to the other, and you'll be left with x equals 3. So remember, this is algebra. You can always check your answer by substituting it back into the original equation and just seeing if it is equivalent. Not that you have to do it, but just a way to check in case you want to. If I were to replace x with 3, so 4 to the negative and in parentheses 3 minus 1 should equal to 1 over 16. Well, let's find out. So 3 minus 1 is 2, 4 to the negative second power. That is the same thing as me saying 4 to the second power in the denominator, because when you move an exponent and its base from numerator to denominator, it changes the exponent sign. So this would give me 1 over 16, which is what I had on the right side. So it works out. All right, guys, I hope this helps.